Welcome to page 1 of your probability packet. You should be on lesson 1.1 on probability. Today we're going to be discussing the probability scale and the definition of probability. When we measure probability, we are measuring the chance that an event will occur. And when we measure that probability, we measure it on the probability scale. We're basically measuring chance, the chance that something's going to happen. Whether it's rolling a 6 on a number cube or picking a king out of a deck of cards, we can measure the chance or the likelihood that it's going to occur. Let's take a look at our probability scale. The probability scale starts at 0. Please write down a 0. And on the high end, it goes to the number 1. Let me give you an example of each. Let's take a 6-sided number cube. If I roll a cube, I could roll a 1, a 2, a 3, a 4, a 5, or a 6. If asked, what's the probability of rolling a 7, we know it's impossible to roll a 7 on a 6-sided number cube. That would have a probability of 0. It would be absolutely impossible. On the other end of the spectrum, down here, we have a probability of 1. What's the probability on a single roll of the same cube of getting not a 7? Well, if you look at all the possible outcomes, 1, 2, 3, 4, 5, or 6, all of those are not a 7. So it would have a probability of 1. It would happen for sure. It would be certain. If you are right in the middle of the probability scale, you have what is called an even chance, or a 50-50 chance. For example, what's the probability of rolling an even number on a 6-sided number cube? Well, let's take a look at our outcomes. You could get a 2, a 4, or a 6 on a single roll and be a winner. You have a 3 out of 6 chance, which reduces to 1/2. That particular event, rolling an even, has a 50-50 chance of occurring. As you move closer to 0 on the probability scale, we see the chance of that particular event becomes less and less. In fact, the closer you are to 0, the more unlikely an event is to occur. That is called being highly unlikely. However, on the other end of the probability scale, as you increase the value of the probability and get closer and closer to 1 on the probability scale, the more likely the event will occur. This is what we call highly likely. It has a much stronger chance of occurring than something that's highly unlikely. So, let's take a look at the probabilities we've been given. Many times we think of a probability in fraction form. We have 0/4, 1/4, 2/4 or half right in the middle, 3/4, and finally we know 4 out of 4 parts is equal to 1. But we can convert each of these to a decimal and express our probability as a decimal. Simply divide to convert. 0 divided by 4 is 0. 1 divided by 4 is 25 hundredths. 2 divided by 4 is 0.5 or 50 hundredths. 3 divided by 4, 0.75. And 4 divided by 4 is, of course, 1. All of these probabilities can be expressed in decimal form. And finally, we can convert all of these decimals to percents. Simply multiply by 100 and move the decimal point 2 places, and we can convert each of these to a percentage. 1/4, of course, is equivalent to 25%. 2/4 is equivalent to 50%. 3/4 is equal to 75%. And of course, 4/4 is equal to 100%. Let's try some probability problems and rate the likelihood of each of the events based on the probability scale. Let's take a look at the 8 cards we've been given down at the bottom of the page. Each card is the same size and the same shape. So on a single draw, each card has the same chance of being drawn, which means they're all equally likely. Let's read together. Express each probability as a fraction, a decimal, and a percent. 8 cards are mixed together. 1 card is selected. What is the probability that? Now we have 8 possible outcomes. We could draw a 1, 2, 3, 4, a 5, 6, 7, or 8. That's called my pool of elements. Let's look at question number 1. What's the probability of selecting an 8 on a single draw? Well, if we look at our deck, we only have 1 card that would be considered a success. That's an 8. We would have a 1 in 8 chance. Now grab your calculator and let's convert this to a decimal. 1 divided by 8 equals 0.125. As a percentage, when we move the decimal, we get 12.5%. On the probability scale, that's located, if this is 0% and that's 25%, it's in the middle, right about here. It has a very weak chance of actually occurring. Let's go on to problem number 2. On the next draw, what's the probability that we will draw an even card? An even card. Well, take a look at your possibilities. 2's even, 4's even, so is 6, and so is 8. You would have a 4 out of 8 chance of getting that to occur, or 1/2, which of course, as a decimal is 0.5, we'll add a 0. And as we move the decimal 2 places, we have a 50% chance of getting that event to occur. A much stronger chance, you can see we moved down the probability scale quite a bit, but it's still only an even chance at 50%. Let's try our next problem together. What's the probability of drawing not 8 on a single draw? Most of the cards are not an 8. One's not an 8. Neither is 2, 3, 4, 5, 6, and 7. You would have a 7/8 chance. Grab your calculator and divide 7 by 8. You would get 0.875. And as a percentage, which I certainly like to see my probability represented as a percentage, you'd be at 87.5%. That is located between 75 and 100%, right about here. As you can see, the probability of this event means that it's quite likely that it's going to occur. How about number 4? What's the probability on a single draw of selecting the number 10? Well, if you look at our deck of cards, we don't have a 10. So 0 out of 8, or 0, and as a percentage, 0. This particular event is impossible. It lives here on the probability scale, down at 0. And last but not least, what's the probability of selecting not 10? Well, take a look at our deck one last time. All of the cards are not 10 in value. So that would mean it's 8 out of 8, or 1, and as a percentage, it's 100%. It is certain that it will happen. We would mark that particular event here on the probability scale. It absolutely must occur. Hopefully you understand the probability scale a little bit better. Remember, the scale only starts at 0 and goes as high as 1. This concludes the video for page 1.